These problems are involving converting decimals to fractions and fractions to decimals. So we got to remember our general rules. When you're converting a decimal to a fraction, all that matters is what's after the decimal place. We can pretty well ignore this 2 until the end of the problem. What we do is, whenever it's a non-repeating, like this one, a terminating decimal, we count the number of places after the decimal, right? There are 1, 2, 3, 4. And that's how many zeros after a 1 we put in the denominator. So in this case, there are 4, so we do 3125 over 1 and 4 zeros, which is 10,000. So now you think about, how do I simplify this? Well, this is where our divisibility rules come in. And one of our divisibility rules said that if the last two numbers are 25, then it's divisible by 25. So I know 3125 is divisible by 25. And so I factor out a 25. And it turns out that it factors into it 125 times. You could make the division if you don't know that. You just divide 25 into 3125, and you get your answer. Okay, 25 also goes into 10,000, and it goes into 10,400 times. Again, we still have a 25 here, so 25 still goes into it, and if it's a 0, 0, then it still goes into it. 25 goes into 125 5 times, and it goes into 400 16 times. So 0.3125 is 5/16. The 2 we have to now put back on, so our actual answer is 2 and 5/16. And that's the answer. It's also something you could write as an improper fraction, which would give you 37 over 16. Either one would be fine. Okay, as for the repeating decimal, again, the 2 will wait till the end. If it's repeating, we count the number of digits, and then we put it over that many 9. So in this case, it's 57 over 99. Well, again, our divisibility rules, 5 plus 7 is 3, and obviously 9 plus 9 is 18. Both of those are divisible by 3. 57 is divisible by 3 19 times, and 99 is 33 times. 19 is a prime number, so we can't do any more simplifying, so our answer is 2 and 19 over 33. If you made it a improper fraction, it would have been 85 over 33. And either one is a generally acceptable answer. Okay, now we're converting from decimals to from fractions to decimals. Again, we can do the same thing we did up there. We can ignore the 2 and just deal with the fraction. This is when mixed numbers are really nice, because it allows you to do that. So we just do the numerator divided by the denominator. So it's how many times does 16 go into 90, or 9? So we've got to put the decimal in, because obviously 16 doesn't go into 9, then add some zeros to help us out. So 16 goes into 90 5 times, because 16 times 5 is 80. That gives me a remainder of 10. So now I look at 16 goes into 100. Well, 16 goes into 90 5 times, because it's 80. So if you add 16 to 80, you get 96. So it's just going to be one more, which would be 6. 16 times 6 is 96. Now we bring down another 0. We got 40. 16 goes into 42 times, so it gives me 32. And I bring down another 0. This is going to be the last one I need, because 16 goes into 80 exactly 5 times. So 9 over 16 is the same as 0.5625, which you can then just put the 2 in front of, so your answer is 2.5625. And the last one, converting this one, so we just do 11 into 10. Well, 11 goes into 10 9 times. And so what we're going to do is it goes into 10 9 times, and so it goes into 109 times. And so we have 99. And then we bring down the 1 0. Now, 11 doesn't go into 10, so it actually goes into it 0 times. That's where you have to be careful in this particular problem. So we add another 0. And then we got 100 again, so it goes into 9 times. So we do 99 again. But then we have 10 again, and you can start seeing the pattern that's happening. And what gets repeated is the 90. And that same pattern would happen on to infinity. So we write that as 0.90 repeating. And you have to have the 0, because it's 9090. And then we have the 5, so we're going to call it 5.90 repeating is your answer. So that's how you convert fractions to decimals and decimals to fractions.